Hello fifth years. Okay, I'm going to do a separate video for correcting the homework that I gave you yesterday, and then we'll do some more notes. So, question 1 asked us to find certain information. They gave us a rectangular box, so let's do a quick sketch, copying the sketch from the book. We have a rectangular box. The front surface is labelled A, B, F, G, and we've 3 dimensions, C, D, E over here, F, and then the hidden edges behind like that. Now they've shaded in the base of it blue to make it easier to visualize, and they've drawn a triangle, a H back here, a right angle triangle, G to H like that, and H to B, and I hope you can see that this triangle here must be a right angle triangle, and that these triangles, the triangle AHB for example, is also a right angle triangle, and there's an angle in here that they want us to find as part of the question. There's some dimensions. It's a rectangular box, so we know that this is 10 meters. Sorry, centimeters. This is 5 centimeters, and this is 4 centimeters. They want us to find the length of the diagonal GH as shown there. So the first thing we're going to do is sketch out that triangle on its own in 2 dimensions. Makes it much easier to visualize. H, B, and G. We'll fill in the information that we do know. The height here is the same as the height here, so that's 4 centimeters. The distance from H to B, we don't know, but we can calculate it just like we did in our notes, because HB is also part of this right angled triangle along the base of that rectangular solid. So I'll sketch out that triangle, AHB. AHB. A to B is 10. A to H is the same as that distance there, it's 5. And so I can calculate HB, the same thing that I'm looking for over here. Let's call it little h for the hypotenuse. Using Pythagoras' theorem, h squared is x squared plus 5 squared, which is 125, and h is the square root of 125. I'll use my calculator for that, which is 5 root 5. We'll leave it in third form because they didn't say to 2 decimal places or anything like that. So 5 root 5. 5 root 5. Now the angle they've asked us to find is this angle here. Let's call it H because it's at that vertex. I have a right angled triangle and I'm looking for an angle, so I'm going to use SOHCAHTOA. So for part 1, I'm going to use SOHCAHTOA. The 2 sides that I know are the opposite and the adjacent, so I know that tan of that angle must be opposite over adjacent. It must be 4 over 5 root 5. And whenever I'm looking for the angle, I use the tan inverse or sine inverse or cos inverse function. So H must be tan inverse of 4 over 5 root 5. And we'll just put that into our calculator. There I was, flying ahead. Actually, this is part 2. This was the answer to part 1. No, it wasn't. Sorry guys, I've just misread the question slightly. Let me finish part 2. We'll get the angle and then I'll come back to part 1. So for part 2, we're asked to find the angle, the measure of the angle between this diagonal and the base of the box. So we're doing tan inverse of 4 over 5 root 5. And that is 19.69. They didn't say to a number of decimal places, so we'll go to 2. 19.69 degrees. Okay, that was the answer to part 2. Part 2, not part 1. And for part 1, we're looking for GH. We're looking for the length of the line GH. Well, we can just use Pythagoras' theorem for that. Now, having done part 2 first, we could also use SOHCAHTOA, but it's probably easiest to use Pythagoras. So that is the hypotenuse. It's the longest side. So h squared is equal to the other two sides squared and added together. 5 root 5 squared plus 4 squared. And h squared is equal to, if you can put that into your calculator in one go and you'll get 129. So h is the square root of 129. You can leave it in third form for full marks. If you change it to a decimal, do it to 2 decimal places, 11.36. So both of those answers would be accepted for full marks. You can just stop here. In fact, I recommend leaving things in third form and not changing them. There's no need to mess about with decimals unless they ask for it. Okay, so that's the answer to question 1. That was part 1. I apologise for doing it second, and that's part 2. Let's move quickly on to question 2 then. So for question 2, we have a radio mast at the corner of a field. So they've drawn it like this, my radio mast from B to T. There it is. And they filled in some other information as well. They've told us that this is a right angle, so they're making our life a little bit easier, and that these are right angles as well. Whichever way you like to draw your right angles is fine. They said that the angle of elevation from the point A, angle of elevation like we're standing here and looking up, is 25 degrees, and they fill that in on the diagram for us as well. Other information, the height of the mast is 12 meters, and the side of this field is 15 meters. Now, the first thing they ask us to do, let's fill in all the other letters as well. So the top of the mast is T, and we have D and C over here. It's important to have that in so that we can identify what we're being asked for. Okay, the first thing they asked us to do was to, let's turn this slightly, sorry, find the length of AB. So I want to find AB. And hopefully you can see that AB is part of this right-angled triangle ABT. I have an angle, I'm looking for a side, and I have another side. So I'm going to use SOHCAHTOA. Hypotenuse, opposite, and adjacent. I have one side, and there's a side that I'm looking for, so it's opposite and adjacent that I'm going to use together. And I'll use the fact that tan of the angle will be my opposite over adjacent, which means that x over 12 is equal to tan of 25. The unknown is on top, so I'm going to multiply. x is 12 times tan 25. Put that into my calculator in one go, making sure I'm in degree mode. 12 by tan 25. And they didn't say to the nearest whole number or anything like that, so we'll go to 2 decimal places. 5.60 to 2 decimal places, meters. That's the answer to part 1. Now, as soon as I have that information, I'm going to fill it right into my diagram as well. That's 5.6. So that's 5.6 and that's 15. I fill in all my sides just in case I need them for a later part of the question. The next thing they ask us is to calculate the angle of elevation of the top of the mast from sea. Okay, now here's one where you might want to start to pull out your string as you think about these questions. Sea is all the way over in the corner and my mast is over here. Oh, sorry, that's a little bit hard to see. Maybe use this. So any kind of square shape can help me visualize it. And I can imagine my mast standing in the corner like this. And I'm looking for this kind of right-angled triangle. Hopefully you can see it there. Okay, so I want the angle of elevation, the angle that's in here. Right, so the triangle I'm going to be working with, if I draw it, the angle of elevation from C to T. When I do it in my two-dimensional diagram, it can be hard to visualize, which is why I keep harping on about using a piece of string or elastic and your pen to help you. So this is the triangle, this green triangle in here. You can shade it in as well to help you, that can sometimes help you visualize it a little bit better. And you can see them, I must have a right angle in here as well. So when I sketch this out flat, my right angle is down here at B, T at the top, and C over here. And they want us to find the angle of elevation in there at C. Well, what information do I have? I know that that's 12, but I don't know anything else. So I'm going to have to use some other information to find one of these two sides. Now, this side is not part of any other right-angled triangle that I can see at the moment. Actually, ATC, it is one there. But it's easier to use this right-angled triangle down here, using the base. This is familiar, this is what we've done before. So I have a right-angled triangle down here, which will include the side CB. So if I find CB in this right-angled triangle, it's the same CB as I have in this right-angled triangle. Let's sketch it out. Your sketches don't have to be accurate. C, D, B. From C to D is 5.6 because I've calculated that already. And from B to D is 15 because we were told that, which means I can use Pythagoras. That's the hypotenuse there. H squared is 5.6 squared plus 15 squared. 5.6 squared plus 15 squared, which gives us 256.36. And H is the square root of that, 256.36. We'll go to 2 decimal places, 16.01. 16.01 meters. Okay, that's not a final answer, but when I calculate things, I usually put a box around them. So that is going to be 16.01, which means it's 16.01 here as well. Now I'm looking for an angle. I have a right angle triangle. I'm going to use SOHCAHTOA, hypotenuse, adjacent, and opposite. Okay, so opposite and adjacent are the two sides that I'm given, which means I will use tan. Tan of that angle C will be the opposite over the adjacent, and then C will be tan inverse of that. I'm sure if you used 16, it will be close enough to give us the answer. So tan inverse when you don't know the angle, or sine inverse or cos inverse, depending on what you're working with. 12 over 16.01. And that's 36.85 degrees. 36.85 degrees. And that's my second answer. Apologise, we move this over. Now, okay, hopefully that's clear enough. I'll just hold it up, make sure you can see the question and how we worked it out. Okay, part 3, find DB. Did we already do that? Do you know what's after happening? Was I labelled my diagram differently to what's on the screen. So I'm just going to change the question. We're actually being asked to find the length of CB on my diagram here. Well, we've already done that, and it is 16.01 meters. Okay, so there was obviously another way that we could have gone about finding the angle of elevation without finding CB first. I had mentioned this triangle in here, ACT, that's a right angle triangle as well. So you could have used that. And that would have given us this line here. I think the base one is easier to visualize. It really depends on what way you end up seeing the triangles. Part 4. So what's happened now was because I mislabeled it, my part... Okay, I did the hard part first. I've actually done part 4 here because I answered the question. I mixed up my C and my D when I labelled it. So for part 4, I'm actually going to do part 2 at this point. My apologies, guys. I keep doing things backwards today. They want the angle of elevation from the top of the mast from D. So in this question here, they were asking for this angle down here. Okay, let me just clear up that triangle. They want this angle in here. Okay, so again, just in terms of visualizing that, my mast is over here. They want the angle from this point down here. So if I have my string or my elastic, you can see your right angle triangle very clearly then. So they want the angle of elevation from this corner of the diagram. I'm going to keep my letters the way they are because otherwise we're going over the whole thing again. Sorry if this has added to the confusion. So I want to find the angle in here, the angle D. I know that D to B is 15 meters. I know T to B is 12. That's coming straight off my diagram there. That's 15 and that's 12. So I have a right angle triangle and I'm looking for an angle. I'm going to use SOHCAHTOA. This one's actually easier because I already have the values. And it's going to be tan, you can fill in the hypotenuse as well. Tan of the angle is going to be the opposite over the adjacent. So tan of D is 12 over 15 and D is tan inverse of 12 over 15, which is 12 over 15, 36.7 when I go to 2 decimal places, 36.7. Sorry, 38.7 degrees. Okay, that was the answer to part 2. So just to clear up, the answer to part 2, 38.7 degrees, it's the angle of this little triangle along the side. The answer to part 3 was the height, 16.01. They called it dB, but I mislabeled, so it's CB. So they want to find this, they want you to find this diagonal here. And the answer to part 4 is the angle of elevation in here. And that was 36.85 degrees. And now I look at the question, I see they finally did say give each answer correct to 1 decimal place. So I will just correct my answers there. 16.0 meters, 38.7 is fine, 36.9 degrees. No, I already rounded that. Tan inverse 12 over 16. Yep, 36.9 degrees, 5.6 meters. Okay, apologies for the needless confusion there. If there's something you don't understand, hopefully I've cleared up what was going on there, but if there's something that you're unsure about, just let me know and I will go over it again. I can even do it out again if someone is finding it too difficult. Okay, question 3 then. A balloon X is 200 meters vertically above a point Y on level ground. So let's draw our diagram. There's the balloon, 200 meters above the point Y. So as soon as we have level ground, we know that we have right angles. They've given us an angle in here at P, which is 48 degrees. And there's another point also on level ground called Q. Just put it here. Which has an angle of elevation of 34 degrees. Okay, so this whole thing is flat ground, which means that that's a right angle in there. That's a right angle triangle. And also, this one is a right angle triangle. It's hard to visualize them. Find PY and QY. So they want us to find this line here and this line here, this length here. Okay, I'll start with my first right angle triangle, which is already done flat for me. 200 meters, P, 48 degrees, X, and y. I have an angle. I'm looking for a side. Let's call this side P. So I'm going to use SOHCAHTOA. The side I'm looking for and the side I'm given are the opposite and the adjacent. So tan of 48 is going to be opposite over adjacent. That means that tan of 48 is 200 over the side that I'm looking for. Now the unknown is on the bottom, so that means I divide. P is 200 divided by tan of 48. And it's saying correct to the nearest meter, so I'll go to one whole number. P is going to be 200 divided by tan of 48. And that's 180 meters. That's the first part. I was also asked to find the side QY, which we're going to call Q. So let's sketch out a little triangle for that. There's my right angle at Y because it's on level ground, 34 degrees. And I'm looking for the side Q. Again, I'm going to use SOHCAHTOA. Adjacent, opposite, hypotenuse. Tan of 34 will be my adjacent over my opposite. This is still 200, it hasn't changed. So the unknown is on top this time, and I multiply the two numbers together. The Q is 200 multiplied by tan of 34. And that gives us 134.9. They said to the nearest meter though, 135 meters. Now, there's another piece of information. They say the angle PYQ is equal to 84 degrees. What is that angle? PYQ. We're talking about the triangle that's flat on the ground. We don't have any right-angled triangles here. Y is the angle in here, so that's my PYQ. Let's just sketch out that triangle a little bit clearer. We can't assume that we have any right angles here. That's Y, that's Q, and that's P. What do we know though? We know the distance from P to Y because we just calculated it, it's 180. We know the distance from Y to Q because we just calculated it, it's 135. And they want us to find PQ. They want us to find this side here. This is a non-right angled triangle. So we want to use either the sine rule or the cosine rule. You can go ahead and try to use the sine rule if you wanted to, but you'd quickly find that it doesn't work because I don't know either of the angles across from the two sides that I know. So we're actually going to use the cosine rule. It's either going to be the sine or the cosine rule. And I'm telling you that it's the cosine rule. How do you know? Well, you get used to the different types of questions. When the angle is between the two known sides, it's always the cosine rule. But you don't have to memorize that. If you tried to use the sine rule, you'd find it wouldn't work out. So that means, let's call this A. I'm going to call this A. Okay, because the missing side in the cosine rule, A squared is equal to B squared plus C squared minus 2BC cos A, like that. So these other two sides are my B and my C. Filling into that then, I get that A squared is equal to b squared plus c squared minus 2bc cosine of the angle between them, cos 84. And let's put that into our calculator in one go. 180 squared plus 135 squared minus 2 times 180 by 135 by cos of 84. And that gives us a big number there, 45,544.916, and we must get the square root of that. I'm going to see if I can just go backwards in my calculator and put a square root over the whole thing. I might not be able to. Let's see if it works. No, it doesn't work. What if I went here? No, I can't do it. Okay, I'll just have to type it in. So the square root of 45,544.92, and that gives us 213.41. And what did they ask for? Correct to the nearest meter, 213 meters. Okay, so there was an awful lot there, and I'm sure some of you got stuck and want to spend some time going over that. Because this has taken us half an hour, I'm not actually going to move ahead with the next step in the notes at this point. I'm just going to assign you some more of these to practice with, just 2 of them. And tomorrow we'll move ahead with the notes as well. So I want you to do for homework. And the best thing to do with questions like this is to just practice and work on examples with them. It's going to be page 121, question 4. So obviously I will put that into Google Classroom as well, and I'll upload a screenshot of it. And if you guys have any questions, just let me know, and then we'll move on with the notes on Thursday as well. Okay, thank you. I'll talk to you soon.